Welcome. This is Coach Dorf. We're in section 3.3, and we're going to look at a homework example. In this one, we're supposed to find the limit as x goes to infinity of sine of 3x times sine of 5x all over x squared. Now, in doing one of these problems here where we have this limit and we have these trig functions in here, there are two identities or two properties that we want to remember. So the first one is that the limit as x goes to 0 of sine of x over x equals 1. All right, this is one of the properties or identities that's in this chapter, section 3.3. The other one is the limit as x goes to 0 of the cosine of x minus 1 over x equals 0. Now you can take a variation of this one. So for example, note that the first one is equivalent to saying the limit as theta goes to 0 of theta over sine theta equals 1. There's two things I changed there. First of all, I changed the variable. The x is just a placeholder. So it doesn't matter that this is an x, that these are x's. I can replace them with any variable I want. So in the below it, I replaced it with a theta. Notice also that what I did in that one was that I switched the order of what's on top and what's on bottom. That doesn't matter because in the original one, the limit equaled 1. If I take the reciprocal of 1, if I make that into a fraction and flip it upside down, the reciprocal would be 1 over 1. If I flip that, I still get 1 over 1, which reduces to 1. So I still get this value here. Okay, remembering those two facts then, how can we use this to solve problems? Well, notice that the problem we're working on here, the sine of 3x times the sine of 5x over x squared, looks more like this first one that we have because we have a sine term there. So let's explore this a little bit more. If I have the sine, let's say we say x is going to 0, what the first property says is, again, I can have anything I want in that box there, and it's going to equal 1. So the sine of the box over the box equals 1. So that this tells me that if I did the limit as x goes to infinity of sine of 2x over 2x, that equals 1. Notice that whatever I have here has to match what's on the bottom. All right. Likewise, if I did this, the limit as x goes to 0 of sine of 3x over 3x, that equals 1. Again, I have to, whatever I have here has to match here. So what about this case? What if I have the limit as x goes to 0 of sine of 2x over x? What does that equal? Well, I have a 2x in the top, but in the bottom here, I've got an x. Those don't match each other. So I need to rewrite the top one so that it looks, so whatever's in the red boxes matches what's in the green box. So let's look at that and write it this way. The limit as x goes to 0, the sine of 2x. Now I can't really take out that 2x after the sine, but I could put a 2x in the bottom. Now you may say, well, you can't just put a 2x there. And you're right, I can't just put a 2x there. So how do I get a 2x there? Well, I do that by multiplying the top by a 2 and the bottom by a 1. All right, if I did that, if I now then simplify this, these 2's would cancel out, and I would have the limit as x goes to 0 of sine of 2x over x, which is what I had up here. All right, so that's how we can manipulate this in a case like this one where I had whatever's after the sign doesn't match what's in the denominator. Okay, by multiplying terms in there to make them equal. All right. So in this problem, if I were to finish this out here, so if I started with the line here, but did the limit as x goes to infinity of the sine of 2x over x, what does that equal? Well, I would rewrite that as the limit as x goes to infinity of the sine of 2x over 2x. So now I have this match that, but I need to multiply by a 2 up here to balance out with the 2 I had in the bottom. All right, so now what I have here, these two are equal to each other because of the 2 and the 2 there balance each other out. And then what do I notice about this part? Well, the green here, okay, that equals 1 by that property or the identity that we had before. And for the last part, which I'll do in purple here, what's that limit as x goes to infinity? There's no x's in that purple part. So the answer is just 2 over 1, which is 2. And so when I simplify that, I end up with the answer 2. So the original problem, that limit as x goes to infinity, let me do what color haven't I done yet? Do orange here. This limit equals 2. All right, so let's apply that now to the problem we have. So we have the case of the limit as x goes to 0 of the sine of 3x times the sine of 5x over x squared. So I'm going to break this up into parts. So I have the sine of 3x over something times the sine of 5x over something. Now, what do I want in the bottom? I want to have a 3x here below the sine of the 3x so that these two match up. Now, if I do that, I can't just put down a 3x there. So what do I do? I'm going to put a 3x, whoops. I'm going to put a 3x up on the top so that those balance each other out. All right. And let's see, what do I want in the bottom here? I want 5x so that these balance each other out. So now I just can't add a 5x in the denominator, so I also have to multiply a 5x in the top. And then the last thing was, in the very bottom, I had an x squared, and I haven't accounted for that. So I'm going to put that x squared down here, and I can put a 1 down here. If I wanted to, I could put a green x under the 3x, and a green x under the 5x. Doesn't really matter. And now I want to simplify all this. All right, this first part, that equals 1 by the property or the identity that we had before. The second one equals 1, again, because what's in the purple circle, the 3x matches the 3x after the sign matches the 3x in the denominator. And in the red one, the sine of 5x, the 5x in the top matches the 5x in the bottom, so I get 1. What happens when I reduce in, when I get to this part, 3x over x, I've got red here, we've got an x on the top, an x on the top, and that cancels out with those x's there. And so I ended up with a 3 on the top and a 5 on the top. And so when I simplify all that together, I get 15.